Welcome to all. Today's topic is capacity of a parallel plate capacitor. Okay. So parallel plate capacitor. So let us consider two plates P and Q. P and Q. Okay. This is one plate P, this is plate Q. The P is the charged with a charge Q plus Q, and Q is earthed. A negative charge is induced in the inner side of the Q, and also a positive charge induced in the outer sides. As it is earth, this disappears, move towards the earth, that is ground. Okay. So plate, let us consider two plates P and Q. Okay. P is charged with a charge plus Q and Q is earthed. Okay, Q is earthed. Then a unit positive charge. A unit positive charge is placed at A in between P and Q. So a unit positive charge is placed in between P and Q. Okay, unit positive charge. This charge experience a force. So this which experiences a force due to P and due to Q. Due to P and due to Q. Okay. So this, what is the force experienced by this charge due to P? Due to P, suppose that is F1, that is equal to sigma by 2 epsilon 0. What is sigma? Sigma is the surface density of the charge. Okay. And what is the force experienced due to Q? That is F2 sigma by same 2 epsilon 0. Both are in same direction. Okay. So what is the intensity? As force is sigma by 2 epsilon 0, what is your intensity? What is the intensity? Intensity is the force experienced by the charge. Here charge is unit positive charge. So intensity at A due to P is also equal to sigma by 2 epsilon 0. That is due to P. And also force experienced by charge due to Q, that is sigma by 2 epsilon 0. What is the intensity due to Q? Also sigma by 2 epsilon 0. Okay. Now net intensity. What is the net intensity? Net intensity E is equal to E1 plus E2. Means E1 is sigma by 2 epsilon 0, E2 also sigma by 2 epsilon 0, that is equal to 2 into sigma by 2 epsilon 0, that is sigma by epsilon 0. So, net intensity is sigma by epsilon 0. So, E is equal to sigma by epsilon 0. This is the direction of E. Okay, sigma by epsilon 0. Sigma is the surface density of charge. Suppose now let dV is the potential difference between two closely situated points, potential difference between two closely situated point around A. So, around A there are 2 points. Potential difference of that point, 2 points is dV. So, dr is the distance between them. Distance between them. Okay. So, what is the potential difference between these 2 points? So, that means dV is equal to negative of E dot dr. Okay. E dot dr is the intensity, dr is the distance, dV is the potential difference. Okay. So, what is E dot dr? That is equal to minus E dr cos theta. What is theta? Theta is the angle between E dot dr. That means as the unit positive charge is away from the Q, away from the negative charge, so the angle between the E and dr is 180 degree. 180 degree. So, that is equal to minus E dr cos 180 degree. Okay. Angle between E and dr is 180 degree. So, cos 180 is minus 1. So, minus E dr into minus 1, that is E dr. So, potential difference dV is equal to E dr. Okay. So, dV is equal to E dr. So, now what is the net potential difference between P and Q? Here the distance between these two is d. Okay. D is equal to distance between two plates. These two plates are parallel to each other. So, it is parallel plate capacitor. So, dV is equal to dr. For net potential difference, V is equal to integration dV 0 to V. That is integration E dr 0 to d. Distance is d. Okay, 0 to d. That means at first potential is 0 and final is V. Distance is 0 then to d. Okay. So, that is equal to E 0 to d. What is E? E is your sigma by epsilon 0 into dr. Sigma by epsilon 0 into dr. So, this implies V is equal to sigma by epsilon 0 then integration dr 0 to d. So, sigma by epsilon 0 dr integration is r limit 0 to d. So, that is equal to sigma by epsilon 0 d minus 0 upper minus lower, that is equal to sigma by epsilon 0 into d. So, this is the V, this is V. Okay. What is sigma? Where sigma is the surface density of charge. So that is equal to Q by A, where A is equal to common area of P and Q, two plates. Okay. So what is V? So V is equal to that is sigma D by epsilon 0, that means Q by A into D by epsilon 0, that is QD by epsilon 0 A, that is V, potential difference, net potential difference. Now we can find out the capacity of the parallel plate capacitor. Capacity of the parallel plate capacitor. C, capacity is C is equal to Q by V, charge by potential. So Q by V, so Q by QD by epsilon 0 A. So that is equal to 1 by D by epsilon 0 A, Q cancel. So what is your capacity? Now epsilon 0 A by D, epsilon 0 A by D. Okay. So capacity of the parallel plate capacitor, that is C is equal to epsilon 0 A by D. Okay. This is the capacity of the parallel plate capacitor, epsilon 0 A by D. Epsilon 0 is the permittivity of the medium in free space. That means in between the P and Q, the medium is air. A is the common area of two plates. This is the distance between them. This is all about your capacity of a parallel plate capacitor. That's all. Thank you.